Hello, everyone. Welcome to yet another Google Cloud's Innovator Tech Talk. Today's webinar is about improving security posture in GKE environment with Anthos config management and Anthos service mesh. I'm Arun Ananthampalayam, product manager at Google Cloud. I'm joined by Amir Abbas, who's also product manager at Google Cloud. Today, we are going to spend the majority of our time showing and sharing the best practices you can follow to achieve enterprise-grade security posture in GKE environment. Before we demonstrate, let's get level set on a few concepts and services that we showcase during the demo. We are happy to take questions at the end, so let's get going. So with the past 5 years, Kubernetes has become the de facto container orchestration platform. At the same time, GKE has become the most advanced Kubernetes service. Tens of thousands of organizations have already chosen GKE as their preferred services to run their containerized workload. This is due to Google's history and ongoing investment in Kubernetes and the open source community. To this date, Google remains the top contributor. Despite all this innovation, Kubernetes still involves a bit of assembly and tinkering to optimize for your needs, right? Do-it-yourself, Kubernetes is very hard, as you can tell, right? Difficult is to get started. The many day-to activities can lead to misconfigurations and insecure environments. We know from talking to our customers that a legitimate skill gap exists in enterprise, and core business workloads aren't yet containerized. That's something that we hear often from our customers, which is where GKE comes into the picture, right? So GKE simplifies and reduces many of the infrastructure tasks required for creating and managing Kubernetes clusters. So since 2015, GKE is continuously innovating and always improving on operator, cluster admin, and developer experiences. This makes it easier and safer and less expensive to run Kubernetes. We introduced many advanced features. To name a few security-centric features, we've introduced greater workload isolation with GKE Sandbox, secure access to cloud services with workload identity, and secure supply chain with binary authorization and vulnerability scanning, right? And many other security functionalities. But despite all this, our users are still looking for a more simpler way to build their own development platform with a more secure and consistent environment for their development teams. So to address those challenges, we introduced GKE Autopilot. It's a new mode of operation in GKE. GKE Autopilot is fully managed Kubernetes offering. GKE provisions and manages the cluster's underlying infrastructure, including nodes and node pools, giving you an optimized clusters with a handoff experience. We also introduced Anthos. It's a platform designed to simplify the management of Kubernetes clusters on any public cloud or private cloud. It extends GKE-like experiences with Google-backed control plane for consistent management of services across different environments, right? Anthos can run both containerized and also virtual machine-based workloads anywhere. It's powered by open source technologies like Kubernetes, Istio, Gatekeeper, Knative, and so on. And it is made up of a few core things, which I'll get into it in a moment. You can put these Kubernetes clusters on premises on vSphere or bare metal servers. You can put it on Google Cloud or on AWS, on Azure, or even you can attach your existing Kubernetes compliant clusters like AKS and EKS and manage its lifecycle using Anthos. So Anthos is comprised of integrated set of services to ensure the lifecycle management of any IT organizations, right? So it takes care of operator, developer, and security teams day 0, day 1, day 2 activities, right? And it helps them accomplish their duties without any siloed approach. So let's start with container or fleet management, right? It's a reliable and efficient way to deploy and run containers anywhere. Service management takes care of managing service mesh, offering to connect, manage, and secure both VMs and containers. And policy management to the left takes care of, it's a central place to manage configurations and security policies using GitOps approach. And last but not least, the operation management, an integrated logging and monitoring service for you to take care of management across containers, services, and also applications. Let's get into, let's double click on both service management and policy management, config and policy management in the rest of the webinars. So as you expand your Kubernetes footprint, creating and enforcing consistent configurations and security policies across these growing fleets can create friction. So Anthos config management tackles this by enabling you to set and enforce consistent configurations and policies for your Kubernetes resources. This is regardless of where you're building and running them. It combines three components: config sync, policy controller, and config controller to achieve the goal. GKE customers can now take advantage of config and policy automation in Google Cloud at a low incremental per cluster pricing. You can also use ACM component independently, but they're also designed to work together, right? So let's start with config sync. Config sync continuously reconciles your clusters to a central set of configurations that are stored in or more in one or more Git repository. Policy controller, on the other side, it enables the enforcement of fully programmable policies that represents constraints on desired state, right? These policies can act as a guardrail and prevent configurations from violating security and compliance controls. You can use these policies to actively block non-compliant APIs or simply to audit the configuration of your clusters and report any violations. Policy controller is built from ground up using OPA Gatekeeper, the Open Policy Agent Gatekeeper project, and it comes with a full library of pre-built policies. We got close to 65, and we're planning to extend it to 105 for common security and compliance controls. So let's dive a little bit deeper into how it's deployed and managed, right? So when you're starting out, it's simple, right? To give, you're giving each dev team their own cluster. But then that team may quickly outgrow their clusters, which means you now need to provision the same environment across multiple clusters. This happens when you need redundancy, staging, and production environment. And now think about multiple regions, right? Things can get quite complex. The cluster sprawl can easily happen. So you end up with X tenants times Y namespaces times Z clusters means exponential growth in number of policies that you'll have to manage. So in many production deployments, you're often see broad use of imperative operation, right? But that's something of an anti-pattern for Kubernetes, because Kubernetes is all about declarative state. So how do we take this approach and transition it from imperative to declarative is what the ACM is good at. So we start with a Git repo, something almost every technical practitioner is already familiar with, like GitLabs, GitHubs of the world. We store all our deployment state there, like could be namespaces, pods, services, secrets, any Kubernetes object, right? You name it. And we use that to declare the state of deployments. So now the process of deploying the new software looks a lot like a standard development process, which the developers are already familiar with. Teams can branch the deployment and have their changes merged back into the main repo, just like the way you're checking your code. At any given time, the state of your deployment matches what's in the Git, which is the single source of truth. So just like you tag and release software, we can now apply the same principles to the state of our deployments now. So if you need to roll back, revert a commit. If you need to create staging site that looks like a production environment, create a new branch. And did an imperative operation change any existing deployment configuration? Anthos config management can actually fix the drift and put put things back to their declarative or declared state, right? So it can automatically do that. So let me talk a little bit about the difference between config management and policy management. So policy and config management are related, but definitely not the same. Policy management is about defining rules and rule enforcements. This might sound a lot like Kubernetes RBAC, but RBAC is about who can make any changes, right? Make changes. Policy management examines what the changes is. So that's the stark contrast between config and policy management, right? So with that, I think I've covered most of the concepts and things that's needed to kind of follow along the demo. So I'll hand it over to Amir to take you through the demo with some additional context. And we're happy to take questions at the end.
Thanks, Arun. Hi, everybody. My name is Amir Abbas. As Arun mentioned, I'm one of the product managers on modern platforms. I help customers create modern applications on modern platforms. So this is a very exciting talk for me. I want to quickly talk about how the demo is set up. Majority of this is going to be in the console or in the CLI. And I want to really talk about some of the players that we're going to be dealing with. So at the very top, you have something called a rule definition. In Kubernetes lingo, that's just a CRD. So a policy can be anything, right? Kubernetes is a very kind of an open, unbounded sort of a system. You have YAML declarations. Within that YAML, you can create any kind of policy that you like. For example, you can enforce labels or enforce network policies and things like that. Those are defined as CRDs. So those, you can think of them as your template policies. And then your enforcements, which is the one that's right underneath that, are the actual objects that use those definitions to enforce some sort of a policy on top of that. Once you've defined that, that becomes essentially those both are YAMLs. One is a CRD, which is the definition. One is a CR, which is the actual resource against that definition. Then you deploy those policies onto your clusters. Now, there's multiple ways to do that. You can do it just through kubectl apply. You can do it through just any API client or CI/CD tool, or you can do it through config management. That's what we're going to use today. So we're going to create policies, and we're going to use config management to deploy it. And the reason we're doing that is because we want these policies to stay enforced. One of the things about config management is that it's got a reconciliator built in. And what that means is that even if you go in and you decide to, kubectl delete, let's say, a constraint template or a constraint, the config management will reconcile that change so your cluster remains succinct. Plus, we're going to be using GitOps to do that. Once those policies and the policy constraints are onto your GKE cluster, we have an admission controller. That's at the bottom. That's called the policy controller. And that's built on the open source project, the OPA Gatekeeper project. But it's a managed solution by Google. And anytime you do any kind of kubectl apply, whether, again, it's through any of those three tooling, the policy controller intercepts that request, performs a review on that request. If it's allowed, it will deploy that and send it to the GKE API server. If it's not allowed, then it will give you some sort of a violation. So next slide, let's take a quick look at what some of these definitions looks like. So here's we don't have to read everything, but I just wanted to show you a structure of a constraint template. So these are the definitions. And I'm also going to show you that about 50 of these come kind of pre-built, and there's very rarely that you have to create your own, but this is what they would look like. So this is what will generate a CRD. It looks like just like an open API spec. It generates a CRD. And then there's some code at the bottom where you put in your logic of how this particular policy will be enforced. So if we go to so on this slide, basically what we're saying is that you cannot have a destination rule spec that will allow you to set the TLS mode to disable. That's basically what this little code at the bottom is saying. Now, all this is doing is creating a CRD, but we haven't done anything to it. So if you go to the next slide, you'll see that how do we apply that? How do we enforce this particular policy? So in the kind field, now we're using that destination rule TLS enable that we just created. That's the CRD. You can give it whatever name you want. We can have a couple of enforcement actions. I'll get into that during the demo. And then we can match it to where this thing is applied. You can either match it by the kind, or you can match it by the namespace. You can also do excluded namespaces, and we'll talk about that during the demo. Once this is deployed, what this particular policy constraint is enforcing is that in the default namespace, you cannot have a destination rule that has TLS disabled. That's basically what this is enforcing. So we go to the next slide, please. So it's kind of the same thing. So there's many examples of, keep going, go to the next slide. I want to get to the demo faster. So there's some examples of things that you can do. Like, for example, you can require strict MTLS mesh-wide. This is something we're going to actually use. You can require services to not have service type load balancers. You need to have access logging. You need to have specific labels like your cost label or your org label and those types of things. So now you can see kind of the difference between the actual policy and the guardrail. So think of policy controller as creating a guardrail, right? So I've created a guardrail and I've said, you cannot have a destination rule with MTLS disabled. That's just a guardrail. I have not enforced anything. Now, me as the person that will deploy the destination rule needs to ensure that that guardrail is not broken. And I'll show you that by actually breaking some of the guardrails and then fixing them. So the next slide, please. So then comes in service mesh. Since we are talking about modern platforms and modern application, this is not a service mesh conversation, so I'm not going to go into that. But one of the things that service mesh allows you to do is intuitively place a proxy next to every single workload. Now, these are L7 proxies that come with their own set of functions and features. Majority of the time, a lot of the folks that use service mesh use it for their security features, and that's what we're going to focus on. It comes with observability and comes with traffic controls. We're going to focus on what are some of the security features we can use to make our GKE a safer place to live. The next slide, please. And Anthos service mesh, much like Anthos config management, is essentially what Kubernetes is to GKE, Istio is to Anthos service mesh. So Anthos service mesh is based and built upon the Istio open APIs, but it's a fully managed solution. So Istio does not run into your cluster, it runs in Google infrastructure, just like a GKE API server does not run into your project, and it runs in a Google tenant project. So we have managed control plane, managed data plane, all the boring stuff around service mesh of deploying and upgrading completely goes away. And all you're left with are the front-end APIs, which are completely consistent and compliant with Istio APIs. So you can move back and forth between the two. So it's kind of the best of both worlds. So that's what we're going to be using to deploy some of the security features. And what are those security features? So I'll just kind of quickly show you, and then we'll look at a bunch of YAML in the demo. So if we go to the next slide, and we've been talking about this access policy, for example. So an authorization policy or an access policy allows you to decide how two namespaces or how two applications can talk to each other. So part of the service mesh is every single workload gets a strong identity based on the spiffy spec. You see that on the third line from the bottom where it says principals, you'll see an identity, and that's the spiffy spec. So every single workload gets that as part of the service mesh. Now, these are strong identities. They're backed by X509 certificates. And this authorization policy essentially is saying that the front-end namespace is only allowed to be talked to by the load generator namespace with that particular principle. So it gives you L7 granular policy. You can go, the authorization policy spec is actually very granular. You can go pretty crazy with that by actually supplying exactly which paths, which URLs, and those types of things. But this is kind of a simple example of how you can enforce L7 authorization policies. Next slide, please. Another one is the encryption service to service end-to-end encryption. That particular resource in ASM is called peer authentication. So in this particular case, we're creating a default peer authentication policy in the Istio system namespace with the MTLS mode of strict. Because we're generating this in the Istio system namespace, what we're saying is mesh-wide, we want service-to-service encryption turned on with an MTLS mode strict. It means that no two services can talk to each other in plain text. Probably a good idea to have that into your cluster and maybe put a policy around that so nobody can violate this. And then I believe I have one more slide. So we go to the next slide. This is a destination rule since we've been talking about it. And these are the three things that ASM or Istio provides in terms of the security features that it provides. And so I just wanted to just kind of show you an example. So a destination rule is done on a per service level, where peer authentication policy is done kind of on a mesh-wide level, the one that I just showed you. This one is now scoped to the namespace. So I've created, in this one, we're saying there's a destination rule in the front-end namespace. And at the very bottom, you're saying the TLS mode is set to Istio mutual. So that's the same thing as the MTLS mode set to strict. So you can set the MTLS mode mesh-wide to strict, but you can then come into the specific namespace and you can disable it here, or you can set it to permissive. And so perhaps it's a good idea to be able to have policies that'll also not allow you to do that. So with that, one more slide, I believe that just gives you the demo that I'm going to show. I just created a quick bit.ly link. So if you want to jot that down while I'm trying to figure out how to share my screen. But it will be on bit.ly/secure-gke-asm-acm. That's the closest I could get to it. All right, so Arun, if you want to unshare, and I will go ahead and share my screen. And yes, please feel free to put your questions in the chat. It's probably the easiest way for us to just kind of see that. And we'll just do it at the end because I'm probably going to answer a lot of those questions during my demo. All right. So we're going to start our story with a couple of GKE clusters. I think that's where pretty much all stories start. So I have two clusters, one in West 2, one in Central 1. Really, there's no difference between the two, but what I want to show you is two different enforcement modes of the policies. So there are two modes that you can apply these policies. One is in dry run mode, and then the other one is in deny mode. And hopefully the names are pretty self-explanatory, but in the dry run mode, you can audit the violations, you can audit the policy. It's not going to deny anything. The policy controller will just emit violations. And then you can see that it's a good idea to perhaps put stuff in dry run mode so you don't break anything, eliminate all the violations, and then switch the mode to enforcement deny. So what I'm going to do is I'm going to just show you everything in dry run mode first, and then we're going to fast forward, and then we're going to generate a bunch of violations on the second cluster in deny mode, and then we're going to clean up those violations on both clusters. So both of these clusters have ASM and ACM deployed in and a repo. So if we quickly go, and then I have an application also deployed, but I'm going to scroll down here on the left panel down to config management. And then you'll see that I have the same two clusters. These are registered to Fleet, and you can see that the config sync status is synced. So they are synced. And if I click on one of them, it gives me some more detail. The big one is it gives me the sync repo. So I'm just going to click on that, and let's just quickly review what this repo is. Now, this is just kind of all done ahead of time, so I didn't want to spend time doing this. But very simple repo. I have two folders. System folder that just kind of gives you the version. We're not going to really touch that. And the namespaces folder. So the namespaces folder is where we deploy all of our YAML files that get synced. So let's start with this middle folder, which is the Bank of Anthos. You may be familiar with this. Bank of Anthos is just a sample financial application that's built on 10 or so microservices. The one thing I've done here is I've deployed every single service in its own namespace. So all of these folders represent a namespace. So for example, if I open up front end, that is a namespace. If I go, there's a namespace YAML file, which basically just defines the namespace. I've also added the ASM managed namespace label, and that label allows you to inject proxies, which is what we're going to use to deploy some of those policies. And then I have my front end YAML, so this is my deployment and service. And then because front end is exposed using ASM gateway, I also have an ASM gateways YAML. So this defines a gateway that selects my ASM ingress gateway, and then it defines a virtual service that picks any host, uses that gateway that I just defined up here, which is the ASM ingress gateway, and forwards it the traffic to front end. So pretty simple. No policies have been deployed, nothing. It's just running ASM with the Bank of Anthos app, but in their own namespaces. So this is not very secure. So the goal of this demo is twofold. One is to show you kind of how all the pieces kind of fit together, and the second one is maybe even leave you with some best practices on what are some of the good policies that you should start with. And then we have some other best practices that we can leave with. Here I also have a policies folder. I'm just going to quickly open this up. In the Gatekeeper System namespace, remember each of these folders represent a namespace. I have a referential constraint config. There are two types of constraints. There are just, we can just call them standard constraints. And then there are referential constraints. Referential constraints are constraints that reference another object. And in here, in this config, what I've defined is a list of objects that I'm going to be referencing. Right, so maybe I need to get a list of all the namespaces. Maybe I need to look at network policies or authorization policies. So I've just kind of defined that here. You can make this list as long as you want, but anytime a constraint references another object in Kubernetes, you have to define it here. And then lastly, I just have my ASM or the Istio system namespace folder. And the only thing I've deployed here is that peer authentication that I just showed you. But this time I've deployed it in mode disable. And hopefully you can kind of foreshadow what I'm trying to do here is I'm trying to generate some violations. So I just created a TLS mode disabled. You can think of this as that if ASM was not even deployed. The default for ASM is actually permissive. So I've hard coded it to disable so we can actually start generating some violations. So that's it. This is the config management folder or config management repo. Anything I commit here gets pushed down to the clusters. So that's going to be, for the rest of the demo, that's going to be kind of my my workflow. I'm going to not do any kubectl apply. I'm going to generate some YAML files, which are already there, and they're in the repo. And then I'm just going to do a bunch of cut, copy, paste, but a lot of it is just copying and pasting files, constraints, and constraint templates into the respective folders. Actually, they're going to go into a different folder, which I'll show you. and then waiting until they get synced to the cluster and then looking for violations. So the first few I'm going to do nice and slow, and we're going to look at these violations, and we're going to look at how to deploy them, and then we're going to speed up. Before we even get to that, if we go back to this screen, I also wanted to show you that we can do this through CLI, but I kind of like to do this through console. There's this object browser. I'm going to go to the object browser. And inside the object browser, actually, since I was playing with that earlier, I'm just going to go ahead and reset everything. All right, so inside the object browser, you can browse any object that is deployed to your clusters. So for example, if I want to see services, I can just go to the core and scroll down, and here's the service. So I can see all of my service objects. What I'm going to do is I'm going to drop down on the API group, unselect this, and then I'm going to just type constraint. And I'm going to click on this and hit OK. And then I get this one constraint.gatekeeper.sh API group. And if I open this up, these are all the constraints that come pre-built with Policy Controller. And then I have more, so I can just click on more results and then one more time. And I can see that there are 50 of them. So there are 50 constraints. For example, this one, the second one we've been talking about, and we looked at it in the slides. This is a constraint that ensures or enforces that every single destination rule must have TLS enabled. Currently, I don't have any objects defined to it, so there are no constraints, and that's why you're not going to see it. But we're going to start to see that. So it's a GUI way of essentially just navigating through your cluster. I think it's kind of cool. All right, so let's go to my terminal, reload Cloud Shell, and let's pray to the demo gods that everything works. Okay. So I'm just going to close this side screen. I'm going to open up terminal. Hopefully the font is decent enough. Okay, so I am going to just find some variables just so everything is set and good to go. All right, so the first thing I'm going to do is I'm just going to start defining some constraints. So right off the bat, I'm just going to start copying and pasting some commands, and then I'll explain what essentially is happening. So I'm creating a constraint onto just the GKE1 cluster that says MTLS must be set to strict. So this is the constraint that says in the Istio system namespace, you cannot have MTLS set to disable, which I do currently. Once I've committed that to my ACM repo, I get this short SHA. I can just look at the last three, so 95C. I can go back to my repo, go to main, do a refresh here, and just make sure that it's there. As this last one, I'm actually going to make it a little bit bigger. Let's quickly look at this commit. And I've only created this one file. And if we just open this one file, you can see that I've created a constraint of type policy strict only in only the West 2 cluster, which is this cluster, in dry run mode. So it's not going to actually deny anything. And then I'm positioning that in only the Istio system namespace. Now, once I do that, I can go back to the console and go back to the config management screen. And what I want to see is that these two things back to synced. And so let's make sure that they actually get synced. All right, so this top one, and you can kind of tell by the first few letters that it's getting synced. So this 95C, so the GKE central one is good to go. But I want to make sure this bottom one too, and now the bottom one is also good to go. So now they're there. So if we go back to our Cloud Shell, and if we just do a kube control get constraints, we should see one constraint, which is the MTLS strict. All right, cool. And then so what we want to do now that we're sick, we want to see the violation on that particular constraint. So I'm going to just run the get constraint command, and I'm just looking at status.violations list. And we can see that we have one violation. So in the Istio system namespace, we have a default policy, and spec MTLS mode must be set to strict, and it's not. All right, so that's the first thing. Usually when people deploy service mesh, that's the first thing I tell people to do is to set MTLS to strict at the Istio system namespace is mesh wide, especially if all the services are within the mesh. So it's a good idea to maybe put a guardrail around that. So we haven't created the policy yet. We've just created a guardrail, and we're starting to see some violations. So the next one I'm going to do in no kind of particular order is I'm going to create, this one will set it mesh wide, but somebody can still go in and create a destination rule on a service and then set that to disable. So let's go ahead and fix that. So this next commit I'm doing, I'm essentially just creating a constraint for destination rule that you cannot have the destination rule also, the destination rule must also be MTLS enabled. So that's now committed. So again, we'll go back. You'll see me doing that quite a bit throughout this demo. I'm going to refresh this page. Make this a little bit bigger. All right, so constraint destination rule enabled dry run on cluster 1. Let's quickly take a look at that. And I'm just going to look at this first one. That's the constraint. I actually had to create an actual constraint template because I had to change the API changed. But I'll talk about how to create a constraint template a little bit later. All right, so destination rule TLS enabled only on GK2 in dry run mode, and then it applies to all destination rules. All right, so that is good to go. We'll go back to our clusters and we'll make sure that it's there. This particular error is because it's deploying the destination constraint first before deploying the destination constraint template. And so this error will just go away after config syncs itself. So it happens every single time I do this demo. So now both clusters are synced. Again, if we go back and if we just do a kube control get constraints, now we should see 2 constraints. And we're starting to make our GKE clusters, safer and safer. Okay, let's try it one more time. There we go. So the first one says mesh wide, you must have MTLS strict. The second one says even service wide, you must have MTLS strict. So now if I've pre-created a destination rule in the front-end namespace with TLS mode disabled for this demo. So let's quickly take a look at that. So I'm just looking in the front-end namespace, looking at the destination rule, and I'm just looking at the spec. And in the front-end namespace, I've created this TLS mode disable, very similar to how we created the Istio mode disable in the Istio system namespace. And the reason I did that so we can start seeing some violations. So again, we're going to run the constraint get command and look for status violations within that. So the way to get the violations is you do get on the CRD and then on your CR, and then you can look at the violations. And then you can see again, we have that one violation in the front-end namespace. The TLS mode is set to disable, and that should not be the case. Again, it's in dry run mode, so nothing is breaking. All right. So the next thing we're going to do is we are going to make sure that we have access policies deployed. Now, that's the constraint template that we're going to build. So the constraint that already exists is a constraint that says that you can deploy a access policy, which is essentially an authorization policy, but you cannot use wildcards for namespaces or wildcards for principals. So let's deploy that. So again, very similar. I'm just going to create a constraint, and it's just called source not all auth-z. So you cannot just use wildcards for your auth-z policies. And then I've also created an auth-z policy where I am allowing all essays, right? So I basically created a violation just so we can kill 2 birds here. So now if we go back to our repo and back up here and refresh, I'll show you the 2 files. So this last one, there's 2 files here. So first, let's look at the constraint. So that's the top one. All I'm doing is source not all auth-z, which basically just means you cannot use wildcards in your auth-z policies. That's what this constraint does. And the actual auth-z policy that I created in the front-end namespace actually does use wildcards. And so I just did that just so it generates some violations. So now if we go back here, it's syncing, it's synced now. So now if we look at the violations, we'll see that violation, that it's there. All right, so the next 2, I'll just quickly, or the last one, I'll just quickly deploy. So this is not an ASM thing, but in general, it's a good idea to have network policies. And we have a constraint template already built in that requires that every namespace must have a network policy. So we're just going to create that constraint. Currently, no namespaces has it, so we should see a bunch of errors. So I'm just going to deploy this last one, and then I'll just show you how to create a constraint template, and then we'll go from there. All right, so I've just deployed this. I'm going to go up here, hit back, refresh. Oh, by the way, usually when you're deploying files or constraint templates to a config repo, you're not just doing a git commit, you're hopefully doing a PR and all that stuff. But just for the sake of the demo, I'm skipping that beat. All right, so I just created a network policy constraint. If we just quickly look at this file, here I wanted to show you something cool is you can also include or exclude namespaces. So in this particular case, I don't want network policy in every single namespace. So I don't want to have a bunch of errors being thrown. So I've created a list of excluded namespaces like config management system, kube system, Istio system, ASM gateways. There's a bunch of namespaces I just don't want. You can put any namespaces you want here. So that's all I've done here. So we'll go back here, make sure everything is synced. Everything is synced. Now, if we look at the violations, we should get a bunch of violations. So I'm just going to look at the namespace thing violation. You can see like a bunch of like transaction history, ledger, like none of the namespaces have it. So the last thing, so what I like about this one is this allows you to enforce a specific resource onto a namespace. What if you want to enforce another resource onto a namespace? And that's exactly the constraint template we're going to create. So in addition to network policy, which is this one, I want to say that I want to also create a constraint template that also ensures that there's an authorization policy. So remember, network policies work at L3, L4. Authorization policies work at L7. It's the whole defense in depth thing that Google is pretty big on. So let's just make sure that both of them exist. So for authorization policies, we already have one that says you must have a granular authorization policy. You cannot have stars or cannot have wildcards. But we don't have one that says you have to have an authorization policy. So you could create no authorization policy and you're not breaking any policies. So let's actually generate a policy for that. And for that one, we're actually working on making this standard, but since it doesn't exist, I'll just create one. So I'm just going to create a constraint template this time, not a constraint. This is just the template. So this is just a CRD, and we're going to commit that to our repo. Let's take a quick look at what that looks like. So let's go back to this, refresh. I'm actually just going to look at it here in the file browser because it's much easier to look at. Now you'll also notice that there's a cluster folder. So all of my policies are going into the cluster folder. They're not going into the namespaces folder because they are GKE wide. So you can think of the cluster folders, all your CRDs, anything that's cluster scoped goes into the cluster folder. So here I've created at the very bottom the Kate's require namespace auth policies, which is named very similar to the Kate's required network policy. So call it whatever you'd like. That's what I called it. I called it Kate's require namespace auth policies. The bulk of it is here in this green section, the Rego. And essentially, this is where I was talking about referential constraints earlier. Here I'm referencing namespaces. I need all the list of namespaces. So that's what I'm putting. I'm running this function, namespace has auth policies, which is down here. This function takes in one parameter, which is the namespace. So it's the object in review. Give me the name of that object, which is essentially the namespace name. It looks at if there's an authorization policy by checking the inventory of that namespace, iterates over every single object in that namespace, and then looks for authorization policy and it iterates over that. That's the brackets with the underscore. It's just like an iterator. If it does not find it, then it spits out a message and it just says namespace yada yada does not have an authorization policy. So I literally just took the network policy namespace and it's changed that. This is why I had to create the referential constraint, because I need to be able to inspect these objects in real time. So that's what we've created, but we have not really created a constraint against it. So let's go ahead and do that. I probably could have done that in one step, but I didn't. So I'm just going to now quickly create a constraint against it. So almost there. And once that is committed, again, if we just go back, refresh this page. Oops. Go back to my repo. Look at this last commit. So this is the actual, and it looks very similar to the no network policy, or the every namespace must have a network policy thing. Again, just on cluster 2 in dry run mode, and the same excluded namespace, the exact same thing. But now this is enforcing a specific resource into a namespace. So I thought it would be a good idea to add that, because you may want other resources that you may want to enforce that every namespace has. Network policies, destination rule, and authorization policies we think is kind of the bare minimum. So that's basically what we've done. So let's just quickly review. I'm just going to clear everything and let's just take a look at all the constraints that we've defined so far. And let's just quickly review what they have done for us and how they've made things a little bit cleaner. So I don't think the last one is fully deployed, so I'll do another one. But let's just go through step by step. So policy strict constraint. What that does is make sure that MTLS strict is enabled mesh-wide. Destination rule MTLS enabled. What that does is you cannot disable MTLS at a service level, at a namespace level. So even your destination rules must be set to Istio mutual. Require namespace network policy. That makes sure that every single namespace has a network policies. Source not all auth-c means that you cannot have wildcards in your sources. And then if I just do this command once more, we should probably see the last one. And it is in the middle somewhere. Yeah, it's right here, the second one now. Require namespace auth-c policy. So require namespace auth-c policy, require namespace network policies are essentially just enforcing some sort of a constraint. So this is happening now. Now, if we just kind of like step back and look at how we've made the GKE a little bit safer, is because we've added a bunch of constraints and they are all kind of security related, right? MTLS is now enabled. You cannot disable it. You have to have network policies, which means that you have to tell as a service producer, you have to tell which services can talk to you and which services you can talk to. And then same thing as a service producer on the authorization policy side, you have to tell which services can talk to you and not talk to you, right? So policy controller is putting the guardrails. ASM is enforcing that you actually make these policies happen. So the last thing I'm going to do, and then we can probably actually open it up for questions because it's going to be a little bit repetitive. I'm actually going to put all of this policy. So we're just going to fast forward. We're going to put all of these 5 policies in cluster 2. So that's all I'm doing. Nothing changes. The same 5 policies. The only difference is now we're doing it in enforcement mode deny. So that's the second enforcement mode, which means that we should actually start getting some errors. So we've just placed these 5 files, which are the same things that we were just looking at. Again, if we go back to our repo, and we just refresh this page. And this is cool. This is why I like doing things in Git. And by the way, you can use any Git. I'm just using source code repository because I can see all of my policies in a single space. So if we go to any one of these policies for GKE2, the only really thing that changed is the cluster selector, which I guess I totally kind of skimmed over. So in config management, if you can either define resources on a per cluster basis or on all clusters. So if you define this annotation, then you can define which cluster you want to put that particular resource to. So this resource, we only want to put it on cluster 2 or this cluster central 1 in the deny mode. Now, if we go to the status, boom, now we're seeing a bunch of errors just on cluster 2. So like cluster 1 or the West 2 cluster had enforcement mode dry run, but cluster 2 now is giving me a bunch of errors, right? And that's essentially what we want to resolve. So while we're doing that, I mean, I can keep talking. Essentially, I'm just going to go through how to resolve these and make cluster 2 safe, I guess. Are there any questions? Can we start taking some questions on the chat? Okay, so the first question was, the picture depicts if policy controller runs outside of the GK cluster. Is that correct? No, it is not. Policy controller runs inside of the GK cluster. Actually, I can show you that. So let me clean this up. So let me say kubectl get -n. What is it? Config. Actually, I'm just going to do it through GUI here. So if I go to workloads, I just can't remember the namespace name, and I didn't want to just like fumble through it. It is called Gatekeeper System. If I just look at this particular one, I have 2 gatekeepers and 2 auditors, and these are the policy controllers. So these run inside of the cluster, at least today. So that was an easy question. Okay, so keep typing your questions. I will start talking on kind of what I'm working on next. So let's go one by one and let's resolve these violations because we haven't done any resolving yet. So the first one I'm going to resolve is the MTLS strict mesh-wide. So the only thing I'm going to do is I'm going to change that MTLS disable in the Istio system namespace to MTLS strict. And that's exactly what this particular commit is doing. So once that is done, actually, if we go over here, go back to config management, while that is syncing, if we just quickly look at this error, I think it's at the very bottom. Yeah, this one, pure authentication must be set to strict. This one we're assuming would go away. So these errors should go down to 10 once we start seeing it. And in the repo, if I just refresh this page, the only thing I'm doing, go back to files, let's go back to main, go to ASM Istio System peer authentication, I've just changed that to strict. And so that should resolve that error. So now you can see it's 10. So that error is gone. As a matter of fact, if I just click a couple of times and look at that violation again, it's gone. So now MPLS is good to go. We're no longer broken there. The second error I wanted to resolve is the destination rule. Remember, in the front end, we have a destination rule where in the namespace, we have MTLS disabled, and we want to make sure that that's not the case either. So now we can fix that by creating the destination rule that is Istio mutual. So pretty similar to what we just did. And I'm just going to kind of fast forward through that. The next one we're going to make sure is that we have access policies that are granular. Remember, we have an access policy that is set to star right now. And the violation for that looks something like this. So currently it says source principal cannot be wildcards. So let's fix that. So I'm going to, again, basically create an authorization policy. And we'll look at all of these policies at the very end. So essentially, I'm creating an authorization policy that takes that star away and gives you a very granular authorization policy. And then the next one we can fix is the big one, which is traffic control or network policies, right? So if we look at the network policy one, that's the big one. So that's like 10 errors, I think, that we're getting that we don't have network policies. So I'm just going to run a for loop and create network policies. Now, what we haven't created, and this is maybe an idea for a constraint that I just thought of, is maybe create a constraint template that says your network policies cannot allow all either, and you need to have granular network policies. Even though my egress policies are not granular, but my ingress ones are. So this is basically just generating a bunch of network policies in every single namespace. So that error should go away. And then another one was auth-z policies must be in every single namespace. So if we look at that violation, so this basically is saying that none of the namespaces have the authorization policies. So we're going to do a very similar thing like we just did for the network policies. I'm just going to run a for loop and create a bunch of authorization policies. It's also good to do that in like commits, so you can actually look at your commit history and see exactly what I did in this demo instead of just doing it kind of ad hoc. That should probably do it. So if we go back to our repo, I'm just going to go back to main and just refresh real quick, and we're just going to stay in this files thing. So if we go to, for example, Bank of Anthos, let's go to front end. So, and now you can see that there's more stuff here in the front end namespace before there wasn't. And so let's look at some of the good stuff. So like auth-z policy. So now I have an authorization policy that's very granular. I also have another authorization policies where I've just allowed every single thing just so my application can work. I have two network policies. I have an egress one. This one is egress allow all, by the way. And then I have an ingress one, which is a little bit more granular for the namespaces. I also have a destination rule, which is now set to Istio mutual. So it's making sure that it's ensuring that services talking to it cannot talk on plain text. And then the last one is actually in the Istio system namespace, which is the peer authentication. And that is set to strict as well. And so now if we go to status details, we're back to synced. Everything is clean. Everything is healthy. Everything is good to go. That is the end of my demo. I think we still have a few minutes left. So I'm going to see if there are any questions or if somebody else wants to see anything else here. So while I'm here, I'll just show you a couple of links. So I've already mentioned this link, which is my repo. So if you want to do that, just put bit.ly in front of this thing. So bit.ly/secure GKE ACM. And that's it starts from scratch. So just all you need is a blank project. And then it just goes through step by step, very imperatively what I just kind of went through. So hopefully you'll find that useful. If you want to learn more about mesh, you can go to cloudgoogle.com/anthos/service-mesh. And if you want to learn more about config management, again, it's the same link, cloudgoogle.com/anthos/config-management. We'll take you to the main pages, and then you can learn more. So I think showing kind of how these pieces fit together is useful. So hopefully this was educational or somewhat. You learned something. And if you have any questions, yeah, we'll take them now.